Alright, let's open up to page 48. We're going to take a look at some trig limits today. Actually do some practice examples. That seemed to be the response from last night, that we're not doing too bad. We just want some more examples and things to practice. That's kind of your response every time, which is fine with me. So we're going to do these today, and then tomorrow I'm going to let you go to the boards and try some on your own, okay? But I want to make sure we're all on the same page first. Last night, we talked about two special trig limits and then one identity that would be useful to know. So we're going to write those down at the top of the page. That way we can reference them as we go through these different examples. So if you need a reference, go ahead and do that. But can we bring back, remember from last night, the two trig limits that would be useful to know and the one trig identity? What do you think, Anuj?
The limit as theta approaches 0.
Yep.
Sine of some constant theta all over that same constant theta.
Yep, and what did that equal?
That's equal to
1. Okay, so we have two stipulations in order to use this limit. The first one is the variable, whether it's x or theta, whatever it may be, it has to be approaching 0. Okay, if it's approaching anything else, we cannot use this. So it has to be approaching 0. And the other stipulation is those c's, those coefficients, have to match. So if it's like sine of 4 theta over 6 theta, we can't use this identity, at least with the way it looks. And we'll see some examples of that today. So it has to be approaching 0, and the coefficients have to match. That's one of them from last night. What's the other trig limit? Kind of similar. You want to keep going? Yep.
Yeah, sure. Limit as theta approaches 0.
Yep.
1 minus cosine of theta, c theta, all over c theta.
Yep. And what did that equal?
Equals
0. Okay. So same stipulations. We have to be approaching 0 with a variable, and the coefficients have to match. Okay, we'll take a look at that one today. So those are the two trig limits that we have to recognize and be familiar with. What about the trig identity? Kind of the big one from last year. Go ahead, Christian.
Sine squared plus cosine squared equals 1.
Equals 1. So sine squared plus cosine squared equals 1. I'm going to write that better. That didn't show up right. All right, so sine squared plus cosine, I'll get it right eventually, squared equals 1. Again, we can use x's or thetas, whatever the variable might be. So as we go through some of these examples today, we're going to try to look for, if needed, okay, I'm not saying we're going to have to use these every single time. I'm saying if we come up with like a 0 over 0 or some type of issue, maybe we can use one of these. So don't force it, okay? Don't feel like you have to use one of these. They're just handy to have when available. So if we check out the first one, what do we always try first? Substitution. Plug and chug. All right. So we're going to substitute in 0. Now, at first glance, notice how we are approaching 0. So we could use one of these limits up here if we have to. Okay, so that's one of the stipulations that's checking out. But let's plug it in anyway and see what we get. E to the 0 power? 1. Cosine of 0? That's 1. We got to know that unit circle, at least the first quadrant. And all over 4. So our limit value? 1/4. We're done. Okay, remember our flow chart? If you plug in a number, get out a number, that's our limit value. Okay, we just have to be careful with the 0 over zeros and the number over zeros. All right, let's try number 2. Okay, plug it in, see what you get. Sine of 0? 0 over 0. Bummer. There's a hole. All right. So, In our previous limit studies, we would kind of go through a list of options we have. We could try to factor, not going to work out here because nothing's squared. We don't have to use a conjugate because there's not a square root. We only have one fraction, not multiple fractions, so we can't really use fraction properties. So those are out the window. We are dealing with trig, so maybe we can use one of these. Notice how we don't have a sine squared or cosine squared, so using that identity might not be useful. Maybe we can take a look at one of those two. What do you notice? Does the way this look now sort of look like one of those two? Yeah, which one?
Middle one.
The middle one. Okay, notice how we're approaching 0. That's one of the stipulations. And the other one is the coefficients have to match. Notice how this coefficient is 4, whereas this coefficient is 1. Okay, so they don't match. But maybe we can use some strategy or algebra to get them to match. One thing that's kind of tricky with trig is sometimes we put the theta or the variable inside parentheses. At least when you hit a trig button on your calculator, a parenthesis will pop up for you to type something in. So even though they're not written there, you could think about the parentheses being there. You cannot change that 4. It's kind of trapped inside that trig function. Okay, you cannot change it, you can't do anything to it. But we can change the bottom theta if we had to. So if this is a coefficient of 1 and we need it to be a 4, what do you think we could do? Okay, so if we want to multiply the bottom by 4, because then it would change to 4 theta, it's a fraction, so wouldn't we have to multiply the top by 4? Keep it balanced. Okay, if we do that, we'll have 4 sine of 4 theta all over 4 theta. You cannot change the top 4, but you can change the bottom. So notice how we have this limit, this trig limit showing up. We have the constants matching now, and we are approaching 0. So what is this going to equal? 1, according to the limit, right? So we're left with the coefficient of 4 times 1, which is 4. So our goal with these is to try to get them to match these trig limits. That way we can use the value of 1 or 0 to our advantage. Okay, let's go ahead and try another one. Look at 3, what do we always try first? Substitution. I know, it's like a broken record. Plug in 0. Sine of 0, 0 over 0. Bummer. Okay, so there's a hole. We got to ask ourselves, can we factor? No. Do we have to use a conjugate? No. Do we have to use fraction properties? No, because it's only one fraction. We're dealing with trig. Can we use the identity? Well, not the limit. Not right now, okay, because they're squared and nothing squared's in there. So maybe we can use one of these, okay? Kind of, sort of, looking like the first one, right? Unfortunately, the coefficients don't match, okay? You cannot change the top 2 because it's trapped inside the trig function of sine. But you can change the bottom 3, and we need it to turn into a 2. So what can we multiply 3 by to change it to a 2? 2/3. If we multiply the bottom by 2/3, you got to multiply the top by 2/3. So we have 2/3 sine of 2x all over 2x. We are approaching 0, which is a stipulation, and the coefficients match. So what is this section approaching? 1, okay, according to our trig limit. So we're left with 2/3 times 1, which is 2/3. We doing okay? Yeah? Do you think you can try the next one? Check out 4. Alright, when I tried direct substitution, I got 0 over 0. So we had a little bit of work to do. What did we get just as the final answer? 10/3. Alright, what'd you do? That's awesome. What did we do? Times 5 over 3. Alright, so we would have 10/3 sine of 5 theta over 5 theta. This coefficients matched, limits approaching 0. That becomes 1, 10/3 times 1, 10/3. Perfect. Okay, are we on a groove right now? We're doing okay? We're grooving? We're moving? Alright, let's check this out. Take a look at the last 3 we did, okay, 2, 3, and 4. Take a look at the original equation. This answer was 4. This answer was 2 over 3. This answer was 10 over 3. Can you notice how the answer is related to the beginning equation?
Yeah.
Do you see a pattern?
Yeah.
What is it?
Constant value.
It's the constant or coefficient value, right? 4 divided by 1 is 4. 2 divided by 3 is 2/3. 5 divided by 3 is 5/3, but times 2, 10/3. Mind blown, okay? But this is how we get there, okay, using the trig limits. Okay, this is why it's working. Maybe we want to use that shortcut if you can recognize it, but the limit has to be approaching 0. Okay, that's a stipulation, that's a key. If it's 1, you can't do it. Okay, it has to be 0. Let's check out some different ones. Okay, we'll check out 5 at the bottom. Directly substitute in 0. Tangent of 0? So we're on the unit circle, we're over here, 1 comma 0, y divided by x, 0 over 1, 0. Bottom becomes a 0. There you go. I told you that last year, right? Okay, so 0, 0, we got a hole. We got to ask ourselves, can we factor anything? No. Conjugate? No. Fraction work? No. Trig identity? Possibly. Okay, but there's no sine squared or cosine squared. This does not look like one of the trig limits, so maybe there's something else we can do. Possibly just rewrite it some way to help us out. Can we rewrite tangent as what? Sine over cosine. Alright, and that's all over cosine. So we started with 1 fraction, but now we actually turned it into 2, so we do have some fraction work to do. What do we want to go from there?
Oh, it's gonna be this. It's gonna be like sine squared plus cosine.
We got no squareds going on yet. Instead of dividing by theta,
You have to
multiply by,
multiply that guy.
yep, the reciprocal. Okay, so sine times 1 is sine, and then cosine times theta, we'll have theta cosine theta.
Wow.
There we go.
Wow.
Alright, this is still, maybe it'll be helpful to write it out front. The limit as theta approaches 0. We can't factor anything, we can't use a conjugate, we did fraction work and we're okay with that. There's no squared, so no identity, but can we use a trig limit now? Huh. Take a look at the top of the page. What does it kind of look like?
I'm thinking one of the things.
It's kind of the, well, take a look at the top one right here, right? Sine of theta over theta, as long as the coefficients match, right? What's the coefficient in front of this theta with sine? 1. What's the coefficient of this single theta on the bottom? 1. Coefficients match.
Wow.
We're approaching 0.
Wow.
This becomes 1. So we're left with 1 over cosine.
Which is
Now let's try direct substitution. Cosine of 0, 1 over 1 is 1. Okay, so we actually had a mixture there going on. We rewrote tangent to use that to our advantage, and that kind of led into one of the limits that we can talk about, those trig limits. All right, we're going to keep this train moving.
The bar is sharp.
Check out 6.
That's sharp.
All right, what do we always try first? Substitution. All right, cosine of 0. 1, square it is still 1. So we're left with 2 times 2. Or sorry, 2 minus 2. 0. 0 on the bottom. Okay, so we got to ask ourselves, do we have to factor? We definitely don't have to use a conjugate. It's only one fraction, so we can leave it the way it is. We're dealing with trig, so maybe we can use one of the identities or the limits to help us out. Where do you want to go from there? What do you see, Christian?
I want to take the 2 out of the top and then use the trig identity.
Okay, so if we factor out a 2, looks good. And then you said use an identity. So what do you mean by that?
I mean, since you have your cosine squared plus sine squared equals 1, you rewrite it. So it's 1 minus cosine squared equals sine. So then you can put sine squared in there.
There you go. All right, so 1 minus cosine squared is a manipulation of that trig identity, like if you were to rearrange some of the terms. So this can become sine squared, and we still have theta on the bottom. I know. Look at us going from here. So, can we keep going? What trig limit do you see?
I'm seeing the sine one.
This.
I'm seeing.
It's like, maybe I'm not seeing it.
Oh no, you are. I'm seeing it. So
Okay,
I'm.
I see
She
it.
sees
Well,
you.
it's like the coefficient out front is like 2 sine, and then you have a sine bit.
Okay. Well, let me ask you this. If we have sine squared, that means we're multiplying 2 sine functions together.
Yeah.
So if you want to actually write that out, maybe it'll help you see it a little better. Okay? Notice how the limit is approaching 0. So we could use one of those trig limits if we had to. Okay, so that's one of our stipulations. Now, take a look at this. I don't care which sine function you choose. Maybe we'll just do the last one for general purposes. The coefficient is 1 on top, and the coefficient is 1 on the bottom. So what is this approaching? 1. So we're left with 2 times sine times 1, which is just 2 sine. Let's try direct substitution again. Sine of 0 times 2, still 0. I know. I'm going to tell you guys right now, that's going to happen maybe quite a bit this year, where you go through some work and your answer's like 1 or 0 or doesn't exist. Okay, don't get too beat up about it. It happens.
And off the start, you just gotta guess and check.
Maybe.
1 or 0.
There you go. Guessing and checking, not a bad idea. All right, let's check out 7. What do I always try first? Plug it in. All right, cosine of 0 is 1. All right, so 1 minus 1 is 0, and then we got to add sine of 0, which is still 0. So unfortunately, we get 0 over 0. I know. Now, this one we're going to have to talk about a little bit, because if you look at it, we can't factor anything. There's no squared term, no conjugate, no fraction work. Since there's not a squared, we cannot use a trig identity, and maybe we can use a trig limit. I mean, it is approaching 0, so that could be a possibility, but we have a cosine and a sine in there. So maybe we have to use both. Who knows? Okay. I am wondering if we are familiar with an algebraic manipulation. If you are dividing by one term, what can you do to this fraction? What do you think, Anuj?
You can like split it up into 1 minus cosine
Okay.
Plus.
Okay. Plus that. Okay, so if you're dividing by one term, like one thing, you can break up your fraction. Now you could break it up each individual term. Okay, we'll write it out like that. Okay, you could break it up like that. But if you think about the trig limits, the two that we have, isn't one of them a 1 minus cosine up top? So instead of breaking them up individually, it might be more strategic or beneficial for us to just break up, or rather keep the first two the same, like keep that together, and then break up the signed one after that. You know what I mean? Instead of doing all three, you can chunk them. Okay? Now the limit's still going to 0. So let's check each individual piece out after we broke this up. What's this going towards? 0, right? Because the coefficients match, right? And what's this going to? Can we use the shortcut? Yeah, what is it? 2 divided by 1, right? Which is 2. If you wanted to go through the multiplication, like times 2, it would work out. We did a few of those. But if you can recognize that division, that's all we have. So we're left with 0 plus 2, which is 2. Perfect. All right. Now, I know some of you, I'm going to do this on a calculator real quick. Some of you asked for more calculator help, like trying to evaluate these on a calculator. I'm telling you now, for these types of problems, they would most likely be non-calculator problems. But if you wanted to just confirm it, I want to show you how. So last night we talked about typing in the functions. We're going to go ahead and type this in. Make sure you put the whole top in parentheses and the whole bottom. So we can do 1 minus cosine plus sine of 2. Okay, we'll close that off, and then divided by x. Now if you go to the table, you can start to type in x values to see what you are getting closer to. Now since we're approaching 0, we want to come in from the left and the right. So maybe we'll type in really negative numbers close to 0, and then really a positive number close to 0. Notice how the left-hand side is getting closer to 2 and the right-hand side is getting closer to 2. So you can confirm that on your calculator, but notice how we just did that by hand as well. Okay, so you can double check if you have this available to you. All right, let's go ahead and check out 8. Mother lode. I don't really feel like doing direct substitution, do you?
Yeah.
There's a lot of thetas in there, okay? So maybe we can start to simplify it a little bit before we actually try direct substitution. What do you guys want to do? Let's do it. Okay, so 1 over sine plus 1 over theta times 1 over sine. All right. So we have theta over sine and then plus 1 all over theta over sine. Now by rewriting it, now we have a multitude of fractions. So maybe we can use some fraction properties to simplify it, get it to look a little nicer. Where do you want to go from there? Okay, so we'll change the 1 to sine over sine. That way we have a common denominator. So theta plus sine is a new numerator. We'll keep the common denominator, and all of that is over theta over sine. Where do you want to go from there? We still have a multitude of fractions. Flip it, okay? Instead of dividing by a fraction, bring it up. multiply by the reciprocal. Okay, so that's no longer there. What's going to happen?
Cancel out.
Signs cancel. All right, so theta plus sine all over theta. Now, we never tried direct substitution, right? Something's going to happen. What if we try direct substitution? 0 plus 0 over 0. Bummer, right? So, I don't know if we can go any further with this. Isn't that pretty simplified the way it is? Yeah? Okay. Let's go back to the drawing board. You ready?
Whoa.
Trig limit?
Yeah.
Where do you want to go?
You said.
No. Equals.
What do you notice? This, okay, well hold on. That's only, so take a look up here. We only were able to do that if it was its own fraction, right? You can't just pick and choose what you choose to circle. Yeah.
I'm thinking we break it up.
You're dividing by one thing, right? Let's break up the fraction. So theta over theta is 1, and then we'll have sine over theta. Our limit is approaching 0. So what's this going towards? 1. 1 plus 1 is 2. Wow.
Wow.
Good. Do you guys want to try the next one on your own?
Yes.
Yes. Good. Confidence.
We.
Try it.
Who's the attitude? Not dealing with you. Blind. Alright. First one. Yeah, sure.
Wait, no, I'm not. That's really what. I did it right.
Do we all have number 8 down?
Yeah.
We're good? Okay, I'm going to erase that for a second just because there are multiple ways we can approach this number 9. So I want to make sure that we can see both of them. Okay?
I don't think you definitely when you have sine of x over x, and the limit of this would have been 0. So
Yeah.
No, that's not a secret number.
It's 0 or 1?
It's definitely 0.
I'm pretty sure it's 0.
Look, do you have one?
You add them.
You don't add. You
Which one?
Secret
I
code.
got it.
Addison uses a secret code for trig identity.
Math magic, right?
What you did first?
I feel like we might encounter World War III at some point this year.
With those ones back there.
Yeah. All right, let's settle the debate. What did we try first? What? It depends on what you notice first. Okay, so Griffin, what do you want to do? Okay, so note, if you take a look at the top, both terms have a sine x in common, so you could factor that out, and we'd be left with 1 minus cosine x. Okay, notice how we are approaching 0, so those trig limits might be available to us. Okay, Griffin, did you want to keep going from there?
Yeah, and then I split it up and did sine x over x times, and then 1 minus cosine x over x.
Okay, so this x squared, you could write twice, x times x, x squared. So Griffin saw sine x over x, notice how the coefficients match, and then 1 minus cosine x over x. What's that going towards? 1. What's this going towards?
0.
0. And what were you doing with those two pieces?
Multiply.
So your answer was 0. I like it. Okay? Did someone try something different? Maybe you didn't see the factor of sine? Or did everyone do that?
That way it was definitely. That's
The way that you could put it in the first way.
I tried to break it up.
Oh, say it louder.
I broke it up.
You broke it up. Okay, notice how you're dividing by one thing, right? So you could break up the fraction. Sine x over x squared minus sine x cosine x over x squared. Okay, you could break it up. Now, x squared, you can think about it as x times x. All right, what is this going towards? 1. What is this going towards? 1. Okay, so we're left with 1, but we still have an x down below, minus a cosine left up top over x.
That's where I had it, kidding me?
Good, all right? Fraction minus fraction, they have a common denominator. 1
Oh my
minus
gosh.
cosine x over x,
Point and didn't know what
I'm literally a monkey.
which is what? That's our trig limit,
Yeah,
right?
Megan.
0. It depends on what you see first. If you see factoring, it would work out. If you see single term, like one thing on the bottom, break it up. But it would work out in the end. How'd we do? I understand if you didn't get all the way, but could we at least get some of it written out? Starting to? A little bit? Okay. Good. We'll stop there for today. We will do more practice problems, but you'll be on the boards tomorrow. Okay? You could try some of the homework. But there's no video lesson. Yeah.
Especially for the